Hello, everyone. Thank you very much for joining us for this week's Artex Academy webinar, Designing Calf Barn Ventilation. We're going to get started shortly, but just a few things before we do. You're welcome to put your questions in via the question and answer button at the bottom of your screen, or you can add them in the webinar chat. We'll be taking the questions and answering them towards the end of the presentation. And for now, I'd just like to introduce you to Patrick Rothert, the Territory Sales Representative for Artex Barn Solutions. Patrick?
Am I good to start, Karen, or are we gonna, you want to wait for a couple minutes, or?
No, you're good to go.
Good to go, nice. Oh. All right, so good afternoon, everyone, or morning, or evening, wherever you are out in the world. A little jealous of the evening people right now. One step closer to a nice weekend. So kind of just going over what we're going to be talking about today is designing calf barn ventilation, kind of the fundamentals of it and what we need to be watching out for while we are designing these facilities. So just a little bit quick introduction about myself. Like Karen said, I'm a territory sales rep with Artex Barn Solutions, based out of the Midwest, cover a good portion here in the US for those Midwest states. I do have experience in design work with positive pressure ventilation systems. So I have a lot of expertise in being able to design these tube systems and being able to implement them inside of these barns. Based out of the Wisconsin area, just recently moved up here probably about 2 years ago, and it's been a good change so far. A little bit more about myself. I enjoy golfing a lot. I've actually had 4 holes in ones. I don't know if that's because of skill, probably more so just because of luck. And I'm also, as you can see, a pretty big Kansas City Chiefs fan. Glad that we got the Super Bowl last year and hopefully have 7 or 10 more coming these upcoming years. And that's kind of tough luck for all the other teams out there because my happiness is pretty important to me. So kind of just an overview of what we're going to be going over today. One, we're going to jump into the fundamentals of calf barn ventilation. Kind of do's, don'ts, what we really need to be aiming for, whether it's exhaust fan calculations, air speeds for those calves. Then we'll be jumping into positive pressure tubes, going a little bit into the design work of them, and when they can be applicable into those calf barn facilities and where else they could actually be seen as well. We're going to start talking about power ventilation, so whether it's tunnel ventilating or cross ventilating these calf facilities, along with the air exchanges that we're looking to aim at. Then we're going to jump into a little bit more on the housing side, how to ventilate around individual housing barns, along with going over group housing barns as well, just kind of things that I've seen a lot over these past couple of years, and things to watch out for with those as well. Then one of the biggest things I've been seeing recently, retrofitting an existing barn, talking about what we can do inside those, what to watch out for, things we need to be aiming towards so we can work together with the dairymen or the dairywomen out there to be able to achieve the results that they're looking for. Then going into questions that I ask the dairy, things that I'm prepared for. I know it's a pretty strange world out there right now, and we're not on as many dairies as we would really like to. Or otherwise, if you are a dairyman or a dairywoman out there, it's hard to allow people coming out to your dairy right now. So if we are out there, we need to make the most of our time, and this will kind of help show you an outline of what we are really looking for while we're out there to make our time efficient. And then at the end or conclusion of the webinar, there will also be a question and answering period. So if you can, please hold your questions until the end, and we will get some answers out to you then. So going over the fundamentals of calf barn ventilation, number one and most importantly is that we need to ensure that we're providing clean, fresh air inside of those facilities. Just because if you're not giving enough clean, fresh air, it can cause problems. Nobody wants to be in a barn where it's hot, humid, exhausted air, and neither would that calf. So we need to be sure that we're cycling in fresh air for that calf to be living in, along with exhausting it as well. Another thing is airspeed is very important during that summertime and being able to have the right airspeed in the wintertime. During that summertime, we're looking around 200 to 300 feet per minute. And in the metric system, for those of you out there that haven't converted over to our standard system yet, that is actually about 60 to 90 meters per minute. And in the winter time, we're going to be aiming for about 60 feet per minute, which converts over to about 18 meters per minute. And 60 feet per minute is still considered still air, but it's still slow enough moving that we're still able to exchange that air during that winter time. Just because the two really cycle completely different against each other, especially in the Midwest. We get some pretty hot summers, extremely cold winters. So we want to make sure that we're getting that adequate airspeed to that calf to be able to cooler in the summer. But in difference in that winter, we still want to make sure that we're cycling it through it enough that we are adequately removing that exhausted air through the facility. So she isn't just sitting there in exhausted air, aspirating higher, just things that can accumulate to possibly a respiratory disease that would have to be treated with a veterinarian. So airspeed and providing that fresh air is critical. And that also goes into the next topic, that we need to help eliminate the high moisture and high humidity inside that barn as well. Just especially during that winter time or extremely hot summer months, there can be a high moisture rating inside some of those barns, just because we're not cycling through that air fast enough. And making sure that we're providing that fresh air can reduce that moisture and humidity levels. And it can also dry out the bedding, because it's no longer such a moist environment or hot environment, that when the cows are laying down, it can be a drier bedding, whether it's straw or wood chips or anything of that nature, that we can dry it out for her to lay on. The next thing, and another most important thing, is that we need to have a plan to address for both summer and winter months. Yes, with power ventilating barns, it kind of takes out both in one, just because we can stage those fans to be operating at 100% during that summertime to be able to get a good quality air exchange, and then drop those fans down or stage them or put them on VFDs to be able to operate at a lower fan rate or fan quantity during the winter time. So we're still getting an air exchange without an excessive airspeed during that winter. But if it's not power ventilated, how can you address with having two different ventilation strategies? So if it's, say, a natural vent barn, and during the summer, you're having awesome results. You have an airspeed going through there because the curtains are all the way down. You're getting the 200 to 300 feet per minute in there for the airspeed. But all of a sudden in the winter, you have to close up those curtains and you have lingering air in there. You're not getting the air exchanges in there or anything like that. So there needs to be a second plan in place to be able to troubleshoot for that kind of an environment. So something that we can do is implement positive pressure tube systems so we can supplement additional fresh air into that facility. And while distributing air, it's also going to be creating an air exchange in there as well. So we can have that 4 air exchanges per hour for that winter time. So you're still getting fresh air in the environment without dropping that temperature to an extreme cold. So going a little bit more into the positive pressure tube systems. So number one I want to address is just, how does a positive pressure tube system work? So in this photo, you can see that there's a couple tubes going through this cross vent facility. If you trace that tube all the way over to the end wall, you would find that it's connected to a positive pressure fan. So the positive pressure fan takes that fresh air from outside. It will push that air into the tube, which causes it to inflate. And it disperses that air evenly across the whole entire facility, supplementing it with the additional fresh air. So something to really understand is that each tube is specifically engineered for that facility. This is because that every single facility is different in width, length, ceiling height, and a number of other factors, that when we design these tubes, it's specifically for that single facility. Just because we have certain air throw lengths that we have to be meeting, different air speeds, different CFM per cows, or anything of that nature. So each tube can only be put into that facility. It cannot be shifted and mimicked across different facilities. And it's completely different when you're looking at a mature cow facility or crossfed compared to a calf facility. So making sure that we have these engineered and understand that it is specifically for that one barn is key to success. So as you can see in that tube in the photo, there are holes that are pre-cut and pre-engineered at a specific size and the distances between those holes. So when we're engineering these tubes, a lot of times I'm going to be putting, if you thought of the tube as a clock, it would be holes at the 4 o'clock and 8 o'clock location. So each tube has that pre-cut hole that's going to be dispersing a specific amount of air at each cut hole. So the larger the hole, the more amount of air that can be distributed through it. And when it's getting larger, it also changes the throw distance as well. So when I engineer this, or we engineer this, we can engineer it to place air specifically at set locations to make sure that that fresh air is getting down to those cows in their lying area, just because we want to be sure that we're placing that fresh air at the cow space or the calf space, and it's not being shot into a direction that's not going to be benefiting those cows, because the whole entire point is to be getting that fresh air at an airspeed to cool down that calf and get the fresh air down to her, so it's mixing out that hot exhausted air, pulling it out of the facility and making a better environment for her. So kind of like what I was saying is that this is a great supplemental piece for additional fresh air, whether it's a calf barn or any other kind of dairy housing facility, is that when you power ventilate a barn, your air quality at the inlet is awesome, just because it hasn't gone through any part of the dairy facility. Has not accumulated any exhausted air, any extra carbon dioxide, or any other contaminants as it would at the end of the barn. So when you do put this into your facility, you can use it to supplement additional fresh air at that end of the barn, so it disperses out, mixes with that hot exhausted air, and creates a better environment for that cow. Now we're going to start talking about power ventilating some calf barns. So one thing, especially here in Wisconsin, I see is a lot of naturally ventilated barns. And a natural vent barn works awesome when it's 75, 80 degrees and you have a 16-mile-an-hour wind that's going through the facility. You're getting all the air speeds that you want. But in reality, how many days of the year are you actually achieving that? Is it 20, 25%, or maybe is it 15 or 10% that you're getting those results out of it? Just because you're relying so much on Mother Nature to be able to take care of your facility and create those air exchanges. Now, when we power ventilate this system, all of a sudden, the control is in our hands. We're no longer relying on Mother Nature to be able to create the air exchanges for our calf barn. We are the ones that are creating it. So when designing these facilities, we are trying to target specific exchanges or air exchanges for both the summer and the winter climates. So during the summertime, I am aiming for 60 air exchanges per hour. So it'd be one exchange every minute. And this is going to be providing about 120 CFM per calf in the summer. That's about 3.5 cubic meters per minute for the metric system. And it's enough to be able to provide fresh air along with cooling that cow as well. During the winter time, I'm reducing that all the way down to 4 exchanges an hour. So one exchange every 15 minutes. So it's calculates out to about 30 CFM per calf in the winter, or about 1.2 to 1.4 cubic meters per minute. So the whole entire benefit of this is that I am removing that exhausted air as quick as I can during the summer. I have fresh air coming in at the inlet constantly. It moves down that facility in a minute and it's exhausted out. So I am reducing the humidity inside of that environment. I'm creating an airspeed along with giving fresh air to that calf to create the best possible environment. So kind of like I was saying with that humid air, a large benefit is being able to just take that out of your facility. When I'm going through a barn, I don't like breathing hot, exhausted, humid air, and neither does that calf. So being able to take this out also has the benefits of healthier calves because they're no longer breathing in hot, humid air. It's kind of like if I was to sit down and try to eat a pizza at 95 degrees outside, I can't eat maybe one slice, but if it's 70 degrees inside there, I can eat the whole entire pizza. It's same thing with a calf. When it's that hot and that humid inside that environment, her feed intake's going to be down, or whatever she's eating, her water intake's going to be down. And because of that, she's going to be gaining less weight through the period of her life while you really want her to be packing that on. And it also affects her later into her life as well. Whether it is when she is ready to be breeding and producing that next calf, as that calf potentially has the less potential of what a healthier cow is going to be able to give off for that calf as well. So being able to be sure to provide that great environment with the fresh air, the airspeed has some long-standing effects on each calf. So now we're going a little bit into the housings for the calves, whether it's individual or grouped housing, and this is completely up to the farmer. There's certain management styles that work up to be really good for some farmers and other management styles that work well for others. So that is completely up to the farmer. No other outside influences unless if it's with a consultant or maybe a veterinarian as well. But so individual housings, just kind of give you a rough description of what that is exactly what you see in this photo. You're going to have 2 sidewalls on either side of this calf along with a back wall in there. And one of the troubles with this is ventilation wise is how can I get fresh air down to that calf? And the problem is because that there's so many sidewalls, so many obstructions that we really need to focus on this, just because if we're not getting fresh air down to her, all she's going to be doing is breathing in that hot, exhausted air. So one way to be able to go about this is being able to utilize a positive pressure tube system that would most likely run down that alley or the feed lane there. And I can put my holes at either side pointing downwards toward those calves. And because we can engineer it correctly with the right amount and sized fan, I can place holes at those designated areas to be able to target those individual cow housings. So what that allows me to do is I disperse it, I direct the air directly into that calf stall. I get the right airspeed, I get the right CFM per calf in there as well. And when that air comes down, it mixes that hot exhausted air, flushes it out, and then all of a sudden we have a really great environment for that calf. Another thing that we can really look into for increasing airspeed is using recirculation fans. The recirculation fans can be placed above these calf stalls, and they can be oriented a little bit more on a downward angle, so we're being sure that we're getting the most air down at that calf, but we also at the same time have to be careful that we're not getting too much airspeed. I'm not looking for 500 to 600 feet per minute like I would be with a mature cow in there. I don't want 7 miles an hour just because that creates a draft on that calf and too much of a chilling environment. I'm just looking for that 200 to 300 feet per minute for that money range in there. So we need to be careful for the fan orientation, the fan height, and the fan spacing. And one thing to do is really discuss that with an industry professional, just so you can get the correct layout in there with the fan spacings. But recirculation fans is definitely a good way to be able to increase that airspeed at the calf and be able to move that air down the facility and eventually out. So going into the grouped housing calf barns. So it's a little bit different, and at the same time, it's a little bit easier to be ventilating around because as you can see in this photo, there's not nearly as many obstructions inside this facility like we do see with paired calf housings or individual cow housings, just because you do not have those sidewalls to have to ventilate around. So with this facility, you can see that it's a naturally ventilated barn. We have a positive pressure tube going down each side of the barn that's supplementing with the additional fresh air that will also be running in the winter time to supplement, along with panel fans closer to the feeding rooms in there, and along that center line so we can ventilate around those feeding rooms to make sure that we're getting a good airspeed in there. We don't have dead spots inside of that facility to create the cooling. So kind of going along with what I was saying, just kind of another scenario. This is another grouped housing barn, a little bit different though, because we do have individual calf stalls on one side while it's grouped housing on the other. As you can see, there's slits in that concrete wall that the sidewalls would be sliding in and out to be able to separate those calves. So say that this was a cross-ventilated barn, which would create some problems if there wasn't a second factor in there to be able to supplement fresh air. Just because as that air is being pulled across that facility, that concrete wall acts as a barrier. So when that air is traveling, it's coming in, but it does not have a chance to be able to drop back down and be able to create cooling, create fresh air down at that calf. Something that we could look into is putting a positive pressure tube system down the feed alley there with hole in orientations at that 4 and 8 o'clock location so we can directly target those calves and get the fresh air and the airspeed down to them. Now, on the other hand, let's say that it was a tunnel ventilated facility and you're pulling air down the length of the barn instead of the width. This would be dramatically better for the calves that are in that grouped housing because I don't have nearly the obstructions in there. But you do see that I do still have the individual cow housings on the other side. So I could go tube, otherwise I could also go with a recirculation fan that's spaced out correctly because I can target still those specific areas inside of that calf barn and calf facility, and either one of them would work out pretty well. Another thing that we really need to be targeting for some of these grouped housing calf barns is that we need to figure out where the stinkiest part of the barn is. And a lot of the time is that it's going to be where those wastes are going to be removed to. So most grouped housing calf barns, they have a built-in concrete slant where all the waste can be draining down to. And it's going to be going down to some kind of a grate system where it's going to collect all the waste and it's going to transport it down the barn and out the facility. Now, the thing is that transportation of those wastes is going to start accumulating more of a dirty air environment. So we want to be sure that we're removing that as well, just so the calves at the end of the barn where that's being removed to are not suffering because of all of that waste being accumulated right there or anything else, because it's naturally the back of the barn. And that's just how it works with moving or transporting that waste. So one thing that we can really do to help make that a better environment is by putting exhaust fans down on that end wall where that waste is being transported to. That waste is, or the air from that waste is then exhausted out of the barn, creating an air exchange that's going to make a more suitable environment for these calves to be living in, just due to the air exchange that we're pulling out, relieving it, and pulling in fresh air to supplement. So another thing that I've been working a lot with is retrofitting existing calf barns. So one of the biggest things that we need to understand is, why does the dairy want a different ventilation strategy? What are they working against? What's the problems that they're having? Is it airspeed in certain areas of the barn? Is it air quality? Is it a summer problem? Is it a winter problem? So we really need to work with the dairy to figure out and troubleshoot what's going on so we can provide the best strategy to be able to alleviate those problems and make it a better producing calf barn. So going along with that, in some cases, it's just a brand new ventilation strategy is needed just to achieve the results. It's not a brand new calf barn. There's been a lot of calf barns that I've walked through that the structure itself is great. It just needed a little bit more supplementation to be able to get the results, the end results that that dairy was looking for. And just figuring out how can we make that better with still utilizing what's existing there. So understanding the ventilation styles that are suitable for that retrofit. So One thing is that not all barns have the ability to put tubes in. And so the reason behind this, let's say if you are working with a barn that had insulated ceiling that was 12 feet high. I'm sorry for all the metric people, I didn't write that one down. But so the tube, let's say it's 20 inches in diameter that's being fed from the positive pressure fan. Now, when the fan actually turns off, that tube will deflate. And instead of being 20 inches in diameter or full circle, it all of a sudden becomes like a paper line and becomes 40 inches long. Now, when you're talking about 40 inches with only a 12-foot ceiling height, all of a sudden that's a pretty big obstruction. So the last thing we want is that when the workers are going through cleaning out the facility, removing the bedding, is that we don't want that tube being hit with skid steers or any other implements, just because that can damage the tube and then it has to be replaced. So there has to be another option that we can look at if the dairy is concerned about something like that. So the next thing is maybe, is there enough wall space to be able to switch this over to a tunnel vent system or a cross vent system? But then again, there's still concerns to it, just because that's an added cost. You have to frame fans, wire all those fans. But it's still a great option, but not everybody wants to go that route. You really have to understand what you're working with to be able to provide the best solution. And lastly, maybe it's a natural vent barn, but you're having wind shadows through that barn that you're not having air circulation in an opposite corner of where the prevailing wind is coming through. So I mean, it could be something as easy as putting in a panel fan to be able to stir that air and create airspeed where it's not at. And then keep on going down just so we can continue that airspeed down that whole entire calf barn to be able to create the cooling, create the mixing of air, and to be able to promote that fresh air exchange inside of there. So this is kind of a list that I've started to really work with whenever I'm going out to a dairy. Like I kind of said, right now is some troubled times. It can be hard to get out onto a dairy. It's hard to let people or strangers into your dairy just because you don't know everything that's really going on and you want to be careful. So this is kind of a list that I really work with just because I want my meetings to be efficient, because I don't know when the next time I can get out to that dairy is. Maybe it is tomorrow, or maybe it's a month or two away, just depending on what all's going on. So first of all, one of the main things that I think is extremely important is that you need to understand what's the main goal for that dairy, for that calf barn, whether it's a retrofit or a new build. You need to understand what is the purpose for this dairy. Is it fresh air? Is it eliminating certain humidity? Do we need to create air exchange or air speed? Whether it's a retrofit or a new build, we have to address all these certain things. And being able to walk through with them and talk with them about it all is a huge benefit, because some dairy farmers have only been to a handful of dairies, and with that, even less calf barns. While other dairymen do a really good job at going out and seeing other facilities on tours, being able to understand what's changing, what are new solutions that are being implemented. And that kind of goes along with it, is that when you're talking with them, is there, or maybe you are a dairyman or a dairywoman yourself, is there different ventilation strategies that you have seen when you're walking through barns that really stand out to you, that you just think, oh man, that's really good quality fresh air. How do I implement that into my facility? Or the air speed's awesome for calf cooling during the summer, or during the winter time. That's an awesome air exchange. How can I implement this? And this gives you ideas to be able to start bouncing off of, to really understand a good direction to be moving towards, to create solutions that you're wanting to resolve. The next thing, and extremely important thing, especially when we're talking about cross ventilating or tunnel ventilating, is that we need to know the barn dimensions in there. What's the sidewall height, barn width, barn length, because we need to be able to create an air exchange based off of that specific calf barn, just because no calf barn is the same. And along with that, what are the obstructions that I have to ventilate around? Because maybe the tube is the solution, but I don't know that, because I don't know what obstructions are in there. And just being able to work around everything like that, whether it's a barn plan, whether it's just walking through the dairy for the retrofit, just understanding what is inside that facility that I need to be concerned about or might throw up red flags on a certain ventilation strategy, but I can use option B that's really going to be performing well. And the last thing is there any ventilation strategies that you're wanting to stay away from, or the dairyman or dairywoman wants to stay away from? Not everybody likes tubes. Some people do not think that they're aesthetically pleasing to look at. So you don't want to be working in opposite directions for the same end goal. You want to be working together to be able to come up with the best solution that the dairy is going to really enjoy and is willing to work with for the next 20 years. And that concludes everything with the presentation, and I am more than happy to start talking and answering any questions that you all may have.
Thank you very much, Patrick. So we're opening the floor to questions. You can put them through in the question and answer section or in the chat. I'll just give people a few minutes here to type out their questions. Okay, so first question. When placing exhaust fans on the end wall, are there certain areas where you want to place the fans?
Yeah, definitely. So when placing exhaust fans on that end wall, I want to be sure that those exhaust fans are going to be benefiting those calves as much as possible. So I don't want to be putting them on areas where there are no calves at, and maybe it's on a feed lane, just because air travels the path of least resistance. And when you start putting them on that feed lane, you're going to have rapid air speeds at those locations, but it's not benefiting the cows. So I always try to put as many exhaust fans I can over where the grouped housing beds are at or the individual stalls are at. Otherwise, another place to be putting them at is, like I said, where the manure is flowing to or the waste is flowing to, just so I can remove that dirty air out of the facility and just bring in the most fresh air as possible while I'm still getting the air speeds from those fans on those calves.
Awesome. So would it make sense to add perforations to a stem wall to allow some airflow through the wall rather than over the wall?
That's a pretty good question. So I've actually never seen that happen before, but it is definitely a good idea just because you can get some air going through there if you're putting perforations in there, depending on what kind of stem wall it is, just because I don't want to necessarily putting in so much into a concrete wall that it's going to cause breaking over time due to anything having to expand or contract. But I do definitely see that being as a benefit. Maybe if it was some kind of a PVC stem wall or sidewall or something of that effect, that it is a way that you could get fresh air down to that calf and into it.
Is there any maintenance that you have to consider with a positive pressure tube system?
Yep, so positive pressure tubes do have maintenance to them. Just because they are hooked up to a positive pressure fan. So depending on what kind of fan that is, so if it's a belt drive, you do need to tighten that belt regularly, just because if that belt is loose, it's going to decrease the performance of that fan, which means that it's going to produce less CFM than what that tube was specifically designed for. So it will directly impact the tube just because it's not going to be being able to disperse nearly as much air as what it was designed for. As for the tube, you still need to be able to do maintenance on it. The biggest thing is being able to check the aesthetics of it, making sure that there's not a large hole that was cut because a skid steer hit it. So if that happened, let's say a 3-foot hole got cut into the bottom of it because it got hit by something. So what air travels the path of least resistance, and we engineered it to say have 2-inch in diameter holes. If there's a 3-foot hole in there, a majority of your air is going to be escaping through there because it's going to be traveling through the largest orifice inside that. So making sure that it's in good standing condition, there's no rips in it. If there's small little rips, it's not the end of the world, just making sure that there's not a big chunk out of it that's missing.
Are there some things to consider before putting in a positive pressure tube?
Yep, so understanding that it does take up space. Like I said, they can range anywhere from about 20 inches in diameter to 40 inches in diameter. So making sure you have enough ceiling space to be able to fit it in. It is possible to be able to put them up in the trusses. I have seen that done a couple times, but the biggest thing is making sure that it's not going to be hitting obstructions which could cause tears inside of that tube.
Awesome. The next one is, with positive pressure tube systems, can you heat or cool the incoming air?
Yes, so Dairyland Exchange or Dairyland Initiative has actually done something where they heat the air by transporting it underground. So the inlet will actually be a little ways out from the dairy itself, and it'll suck in air through a tube, transport it underground, and it heats it up. And then that way, when it comes in and gets dispersed down that building, it does heat up that air. So you're not bringing in extremely cold temperatures. The only downside to that is that when you start heating up air at a very fast rate, it can cause humid air. So that's one thing to be watching out for, is that when it does get so cold, you'll notice it inside of your dairy facility that there'll be condensation on the tube and possible drippage. So just be aware to be looking for that, just because if there is so much condensation, it can be a very heavy air that's being transported into that calf barn.
All right, and our last question, how can I prepare for both summer months and winter months?
Yeah, that's a great question. So with power ventilated systems, you're kind of designing for both right at the get-go. Just because you're staging your fans to be on, off, or on VFDs to be able to operate for that summer efficiency along with the winter efficiency. So with natural vent barns, it's a little bit different. Sometimes people will run 3 tubes down the center of their barn. They'll run all 3 during the summertime because you're bringing in more fresh air, creating a higher air exchange rate. But during the winter time, they will shut off the 2 on the outside, and they'll leave the 3rd one in the middle still operating, and that is their winter design ventilation system. So it's still creating the 4 air exchanges every hour in there. And then once it starts becoming warmer out, then they'll kick on the other 2 to be able to prepare more for the summer months.
Perfect. Well, thank you very much, Patrick. We really appreciate this. It was a great seminar. I'd like to invite everybody to join us for the Delicate Balance in Ventilating Robot Barns. This is going to be with Dr. Mario Mondaca, and he's going to be doing this with us on September 11th. So if you're interested, you can visit our website at artexbarn.com, upcoming events, and we will hopefully see you there. So once again, thank you very much, Patrick, and thank you everyone who joined us.
Yep, thank you.